Greetings, lovers of mysticism and the unknown. Welcome to the Incredible Stories channel. We are explorers of the unexplainable and unbelievable. Today, I will tell you an interesting story. Brew up some goodies and enjoy. What do you imagine a black hole to be like? Is it a classic vortex from which there is no escape? Or a dark sphere surrounded by a luminous disk, like in the movie Interstellar? Both capture the imagination and inspire awe. But if we want to understand what such an object might actually look like, we have to go beyond the usual 3 dimensions and consider an infinite number of forms. Clearly, the human mind cannot do this, but it is still worth the effort. Most people imagine a black hole as a vortex. We have to thank artists for this, who try to depict how these objects do to the surrounding space-time continuum. But it actually has more dimensions than can be depicted on the page of an astronomy textbook. The vortex is a generalized, extremely schematic representation of how space and time are deformed as they approach the central singularity. The black hole here can only be thought of as a small circle in one part of the vortex. Or rather, it is the proverbial event horizon from which nothing can escape. We cannot look lower with all our desire, so we are forced to perceive the physical shell, surface, of the black hole in this way. That is, talking about its form, we actually mean the outlines of the event horizon. If we draw this circle into 3-dimensional space, in which we are used to be, we get a sphere, shown in the already mentioned Interstellar. However, the same Stephen Hawking, who spent a lot of effort and time trying to understand the nature of black holes, said that the event horizon does not have to be a sphere in the conventional sense. It has to be just a topological sphere. What is it? Any shape that, without changing the number of holes, can be turned into a sphere. If you take a hollow ball of clay, for example, and drop it on the floor, it flattens out a bit. This is what we need, a topological sphere. Even a heart could be the shape we're looking for, but the universe certainly wouldn't think of creating something like that. Mathematical calculations show that an elliptical shape, for example, is perfectly normal for a black hole. The reason here is approximately the same reason why our home Earth is not a perfect ball. It is flattening due to rotation. But with all due respect to Hawking, we cannot limit ourselves to his ideas. His mathematics is only valid for 3-dimensional space, and the universe can have more dimensions. In 2002, 2 scientists showed that at 4, a rotating black hole, complying with all known laws of physics, would look like a donut with a hole inside. Topologically, it is no longer a sphere at all. The famous picture of a black hole obtained thanks to the Event Horizon Telescope looks exactly like a donut. By the way, to be fair, we should note that this effect is created by the light surrounding the black hole. The dark spot in the center is a shadow cast by the event horizon. Alternative topology, meanwhile, is not limited to the donut. But it is sometimes so hard to visualize that scientists prefer not to visualize anything, making do with pure mathematics. In 2006, researchers suggested that in a universe with 4 spatial dimensions, a black hole's event horizon could represent lensing space. To the uninitiated, this combination of words seems odd enough, but the concept does exist. It is described as a coiled sphere, which is the second simplest topology after the usual sphere. To understand its concept, let's take a circular hairband as an example. This object can be rolled up into 2, 4, or even 8 rings, which look exactly the same when viewed perpendicular to each other. In the case of the cosmic lenticular space, the number of foldings may be incomparably more, but visually the effect will be exactly the same. Meanwhile, in a 4-dimensional universe, the event horizon of a black hole would be a 3-dimensional lensing space. It is not as easy to roll up the layers here as in the case of a hairband, but the basic idea remains the same. In 2022, scientists demonstrated that, mathematically speaking, lens spaces can exist and collapse in almost any number of dimensions. In other words, a black hole can have an infinite number of shapes. It is worth mentioning that researchers, in order to achieve maintenance of such a structure, had to use an exotic kind of matter, which is not considered in our modern models of reality. Thus, all these calculations are incredibly hypothetical. At the moment of time, there is not a single evidence of the existence of non-spherical black holes, nor additional measurements, for that matter, But the flight of scientific imagination, supported by appropriate calculations, is not bad at all. One can find many examples in history when it was subsequently confirmed in our physical reality. What did you think of it? Write in the comments. Be sure to get likes, subscribe to our channel, and check out other amazing stories.